For 3.4.1, we're discussing the idea of composition of functions. And what does it mean when you what it means when you compose functions is that you combine two or more simple functions together to form more complex functions. But it's not as simple as just adding them. And so what you're going to be doing is you're going to be using the equation of the first function as the input for the second function. That seems like a very weird idea to even try and process. So let's start with something simple. If I gave you the function f of x equals 2x plus 1, and I ask you to find f of 3. Well, what that means is that you're replacing x with 3. And if you replace this x with 3, then you must also replace the other x with 3. Because you have to do it to everything. And so f of 3 would equal 2 times 3 is 6 plus 1 is 7. Well, we're going to be doing something very similar to that, except instead of them giving us a number like 3, they're going to give us a function like x plus 2. And so that means instead of x, I'm going to plug in x plus 2. And 2 times x plus 2 is 2x plus 4 plus 1, which is 2x plus 5. And this is what we're going to be doing today. So there's two ways that we can write composition of functions, f of x and g of x. The first one is this right here, and we read this as f of g of x. Okay, and that's just how we say it. So the other one we would say g of f of x. And in this case, x is the independent variable, g depends on x, and then f depends on g of x. And in the other example, g of f of x, we know that x is the independent variable, f depends on x, and g depends on f of x. So I'm supposed to take these two functions, f of x equals x squared plus 1, and g of x equals 2x plus 3, and I'm supposed to find f of g of x. So let's just start off with writing this as f of x equals x squared plus 1. Okay, and what they have done is they have replaced what was in this parentheses here, x, with the function g of x. So that means in the parentheses we're going to write what g of x, which is 2x plus 3. So now x has become 2x plus 3. And if x becomes 2x plus 3 on the left, x must also become 2x plus 3 on the right. So I have now that f of g of x, I'm going to rewrite this with the g of x there because that is the correct notation, is equal to 2x plus 3 squared plus 1. When you read this notation here, when you read f of g of x, all it means is that you replace the x's in f with the function g. So whatever they tell you g is, that means you're replacing all the x's and f with that function. So they told you in this problem that x was 2x plus 3. That meant that I'm putting 2x plus 3 in place of x in f. So I do have to do the box method to work this out, this 2x plus 3 squared, or FOIL. So I'm going to do that over here. So I have 2x plus 3 and 2x plus 3. And if I multiply 2x times 2x is 4x squared. 3 times 2x is 6x. 3 times 2x is 6x. 3 times 3 is 9. And that becomes 4x squared. I have my two 6x's I can combine for 12x plus 9. So I'm going to replace that. So now I have for my next step that f of g of x equals 4x squared plus 12x plus 9 plus 1. I have to bring that down. So it ends up equaling 4x squared plus 12x plus 10. So that is my new function. So looking at a different example, it says that we're supposed to find g of f of x. So what that means is that I'm replacing the x's in the g function with the f function, or with the function f. So remember that, let's see what we had written up here. I'm going to write them again. So we have f of x equals x squared plus 1, and g of x equaled 2x plus 3. So when it asks for g of f of x, then what you're supposed to do is take this part, f of x, and plug it in for x in the g function. So g of f of x is equal to 2, and instead of x, I'm going to put in x squared plus 1 plus 3. Well, that gives me 2 times x squared, which is 2x squared, and 2 times 1 is 2, plus 3, I got to bring my 3 down, and then g of f of x equals, well, I can combine my 2 and my 3, so I end up with 2x squared plus 5. So that would be my final answer. So now looking at the checkup, we're going to do the odd problem, starting with number 1. My instructions have asked me to write the composition g of f of x. What that means is I'm taking f of x, whatever it is, and I'm plugging it in to g. So for the first one, I have g of f of x equals, instead of x in this function, I'm going to plug in 2x plus 1. Well, I can't do anything to that, so that's my final answer. Number 3. Again, I'm looking for g of f of x. So that means I want to take whatever f is and put it in place of x in the g function. So that becomes, instead of x squared, it becomes x plus 5 squared. Well, I can use box method or FOIL, x plus 5. X times x is x squared, 5 times x is 5x, 5 times x is again 5x, and 5 times 5 is 25. So that gives me that g of f of x equals x squared plus 5x plus 5x plus 25. And I can combine my 5x's together to give me x squared plus 10x plus 25. And that would be my final answer for g of f of x. Number 5. Again, I'm looking for g of f of x. And that means I want to take f of x and put it in for g of x. And the way I always remember that is because f of x is inside, that's the one I'm plugging in. So instead of x squared, I have x plus 6 squared minus 1. And I need to do box method or FOIL, x plus 6. So I have x plus 6 times x plus 6. X times x is x squared. 6 times x is 6x. 6 times x is again 6x. And 6 times 6 is 36. So I have x squared plus 6x plus 6x plus 36. And I have to bring down my minus 1. And that's my second row for g of f of x. And then I've got to combine my like terms. Well, I have 6x plus 6x, and I have plus 36 minus 1. 6x plus 6x is 12x, and 36 minus 1 is 35. So this would be my final answer. Number 7. I have x squared plus 4 is for f of x, and g of x equals 2 times x plus 1. So I'm looking for g of f of x. That means I want to take f of x and I want to plug it in place of x in the g of x function. So that's going to be 2 parentheses. Instead of x, I'm going to put x squared plus 4 plus 1. And I can go ahead and combine my plus 4 and my plus 1 together. So I now have g of f of x equals 2 times x squared plus 5. The last thing I can do is I can distribute. So 2 times x squared is 2x squared, and 2 times 5 is 10. So my composite function would be g of f of x equals 2x squared plus 10. And lastly, problem 9. I have f of x equals x squared plus 2, and g of x equals x squared minus 2. And I'm looking for g of f of x, which again means I'm taking f of x and I'm plugging it in place of x. So instead of x squared minus 2, I have x squared plus 2 squared minus 2. I've got to do the box method on the x squared plus 2 squared. So that's x squared plus 2 and x squared plus 2. Make sure you're being really cautious about your math because it's really easy to mess these up if you don't multiply correctly, because this is an x squared here and that's not something we normally see. X squared times x squared is x to the 4th. 2 times x squared is 2x squared. 2 times x squared is 2x squared, and 2 times 2 is 4. So if I write all of that out, g of f of x equals, instead of x squared plus 2 all squared, it's really x to the 4th plus 2x squared plus 2x squared plus 4. And then I have to bring down my minus 2. So I'm just looking to see what I can combine together from my last row. And I can combine my 2x squared and my 2x squared. I can also combine my plus 4 and my minus 2. So I'm going to bring down my x to the 4th. So g of f of x equals x to the 4th plus 2x squared plus 2x squared is 4x squared. And 4 minus 2 is 2. So that would be my final answer.